In this scenario, we have 4 routers. So we configure this scenario in Cisco Packet Tracer. Now we need to connect it by cables. The cable cannot be connected to the port because this port having only 2 fast Ethernet ports. So we need to add one more fast Ethernet port to this. So we use NM4 Ethernet for E. E means Ethernet. We need to fast Ethernet. That is fast Ethernet port. That is W. We need to off the switch of the router. This is on off switch. We need to off, and we can put fast Ethernet module. That is NM fast Ethernet. Here. Now we can switch on the router. By this you can check. Here I add a module, but this module is Ethernet. So I need to add fast Ethernet module. Go to physical, off the switch, remove the last one or the last module that you connected. Now select the fast Ethernet port, that is this NM fast Ethernet 2. Add this on the switch, then go to your CLI mode. Image is decompressing and now router is starting. Now you can check show IP interface brief. You can check here. I add one more module, that is fast Ethernet 1/0. Now I can easily add cable to that interface. This is our scenario. As the picture says, this is our router 1, this is router 2, this is router 3, and this is router 4. I'm giving a name to all these routers. This is router 1. This is router 2. This is router 3. This is router 4. Now here I am using the network as (13.0.0.0/8). Here I am using 14.0.0.0/8. Here I am using 12.0.0.0/8. Here I will configure a loopback. That address is 192.168.1. 13.0/24. Here I will configure a loopback. That address is 192.168.14.0/24. Here also 192.168.12.0/24. Now let's give the IP addresses to each interfaces of the router. First I'm open this router, go to enable mode, configuration mode. Now I'm giving the host name as R3 because this is our R3 router. Interface FA 0x0 IP address 13.0.0.3 space 255.0.0.0. Enter. Here I am using .3 IP address because this is R3 router. Here I am using .1 IP address because this is R1. Here also I am using .1 IP address for this network, for 1 IP address for this network because this is R1 now router. For a better understanding I am using this scenario. For this I am using .4 IP address because this is R4 router. Here I am using .2 IP address for this network because this is R2 router. So here I am giving the IP address for FA0 0x0, then give the command no shut. Now create an interface loopback. IP address for interface is 192.168.13.1 255.255.255.0. Go to the R1, configuration mode, interface FA 0x0 IP address for this is 13.0.0.1 255.0.0.0. no shut. Second interface is FA 0x1. IP address is for 0x1, the IP address is 14.0.0.1/255.0.0.0. no shut this interface, then exit, go to next interface, that is FA1/0. Now give the IP address. IP address is for this interface, the IP address is 12.0.0.1 255.0.0.0. no shut. Move to the next router, that is this router R4. Enable mode, configuration mode, change the host name first, that is R4. I forgot to change the host name for this router. Now I am changing the host name. This is R1. Again go to R4. Now go to interface mode of R4, interface FA 0x0. IP address for FA 0x0 is 14.14.0.0.4 255.0.0.0. IP address. No shut this port. Create an interface loopback. Give the IP address. IP address is 192.168.14.1.255.255.255.0. Now move to the next router, that is this. Go to enable mode, go to configuration mode, change the host name, that is R2. Go to interface mode, interface FA 0x0. Give the IP address is 12.0.0.2 255.255.25. Sorry, here we are using /8, so I'm giving this subnet mask. I'm putting this command no shut. Now creating a loopback. I'm giving the IP address to this loopback, that is 192.168.12.1 255.255.255.0 because we are using CID at 24. Now this is done. Now move to the OSPF configuration. As our scenario says, these are different networks, so I'm creating the different network. For easily recognition, I'm creating this sign. This is area 0, this is area 1, and this is area 2. This is area 1. This is area 2. Sorry, this is area 0 actually, because there are no communication possible without area 0, so we need to add a backbone area, that is area 0. This is area 1 and this is area 2. So area 1 and area 2 directly connected with the area 0. So this is our scenario. We're done with giving the IP addresses. Now the configuration remaining is OSPF's configuration. So first open this router, go to configuration mode. Now give the command for OSPF. Just type router OSPF and the process ID. I'm using 1 for all router. You can change the process ID from router to router. Now advertise the network. Here I'm using, for this R3 router, I'm using 13.0.0.0. Then the wildcard mask is 0.255.255.255. The area ID is area 2. Now the next command is network 192.168.13.0. Wildcard mask is 0.0.0.255. Area ID is 2, because for R3 this interface and this interface, this loopback interface, both are in area 2. So I am using area 2 for both network commands. Now move to area router 4. Go to configuration mode. In configuration mode, just type router OSPF 1 is process ID. Now introduce the network running here, that is 14.0.0.0. The wildcard mask is 0.255.255.255, and the area for this network or for R4 is area 1. Now network 192.168.14.0, and the wildcard mask is 0.255.255.255, and it belongs to area 1. Now move to R2. Go to configuration mode. In configuration mode, just type router OSPF process ID 1. Now type network. Here the network is 12.0.0.0. For wildcard mask for this is 0.255.255.255. This is a wildcard mask. It belongs to area 0. Now the second network is network 192.168.12.0. Wildcard mask is 0.0.0.255. It belongs to area 0. Now the most complex configuration is for this router. This is our FA0/0, this is our FA0/1, this is our FA1/0. Now go to configuration mode. Just write this command router OSPF process ID. Now introduce the network command. I am first introducing the network 13.0.0.0. Wildcard mask is 0.255.255.255, and it belongs to area 2. Here you can see this network belongs to area 2, so I am typing either here 2. And next network command is for area 14.0.0.0. Wildcard mask is 0.255.255.255, and it belongs to, here you can see 14th network belongs to area 1, so I am typing here area 1. The next network command is for area 12 or network 12. The wildcard mask is 0.255.255.255, and it belongs to area 0. Here you can see this network belongs to area 0, so I am typing here area 0, press enter. Now the configuration is done. Now we can check the routing table. So first show IP route. Here you can check this network comes from OSPF. This network also comes from OSPF. 14.1, that is this, it comes from OSPF, and 13.0's network is come from OSPF. If you want to check, go to this router, just check routing table, show IP route. This network, 13th network, is come from OSPF. That network is this. 14th network come from OSPF. That network is this. 192.168.13th network is this, and it comes from OSPF. 192.168 14.0's network come from OSPF. That is this. AI, here you can see AI. AI means OSPF inter area. It means these routers are belong to different area. It not belongs to my area. My area means R2's area. R2 saying this networks are comes from O means OSPF, and these networks are IA for me. It means these are the inter area routes for R2. Here you can see these commands here also. Just type. You can use Control plus C for coming or for going to enable mode directly. Control plus C. Just type show IP route. Here you can check this network is coming from OSPF, and it is also inter area routes. This is also inter area routes and coming from OSPF. This is also OSPF inter area routes. This is also inter area routes for OSPF. Here you can check the other commands also. The other commands is show IP OSPF. You can use here database, interface, neighbor. If we are using here database, then you can check this is router LSA, this is network LSA, this is network summary network LSA. These are some LSAs that are going or that are generated in this scenario. Now instead of database, if we use show IP OSPF only, then we will see number of interfaces in this area is 2. Area has not authentication. It means this area is not using authentication, any type of authentication. Number of LSAs is 7. This is belongs to area 2. Now you can check other commands like show IP OSPF interface FA 0/0. Here you can see the process ID, the router ID, the network type is broadcast, the host is 1. This is the address of DR. This is the address of BDR. This is hello time. This is dead interval. Now the next command is show IP OSPF neighbor. This is the neighbor of this router. That's priority is 1. This router is in full state and this router is BDR. This network ID is router is BDR for me or for R3 that is connected via FA 0/0. Now if you want to change hello and hold interval, then go to your configuration mode. Just go to interface which you want to change hello, which interface you want to change hello. Go to interface FA 0/0. For example, I am using FA 0/0. Here you can type IP OSPF hello hello interval, you can give any, like for example here I am giving 12. By default the hello interval is 10. You can change by 12, but if you change hello interval here, you need to change interval here also, because the same hello intervals router can make neighborship. If this router have different hello interval or hold interval or dead interval, you can see, if this router have different hello or dead interval, or this router have different dead and hello interval, then they do not become neighbor. So we need to change both side. For example, I am using hello interval, and you can give here, you can change the dead interval also. This is dead interval, this is hello interval. You can change coast for specific interface, and these are the message digest key that is a part of CCNP. Authentication and authentication key also part of CCNP. Here you can change the priority for the interface, like priority, you can give priority from 0 to 255, any you want. If you want, you can change cost varies from 1 to 65,535. By this way you can change hello time, dead time, priority, cost, anything you want. The another command that we are using in OSPF, as in RIP we studied about default information originator that creates a default route in a whole scenario. OSPFs also have a default originator command. For giving the default route to whole scenario, we need to go router OSPF 1 process ID, and here you can type default information originate and just press enter. By this you can see that a default route will spread in whole topology. The another command is for making interface as a passive interface. Go to router OSPF and process ID that I am already in. Just type passive interface, then the name of interface like FA 0x0. Just press enter. Then for this OSPF process ID, this interface become passive. This is all about OSPF, and practical part is over. For CCNA,